z value in probability. The only formula that it's going to be in is this one, x minus mu divided by sigma. Okay, so if we want to talk about what each of these values are, x is going to be some value that you have based on a random normal distribution. So for example, let's say you have a normal distribution with mean equals 25 and standard deviation 2. Then suppose then you have like some data point at x equals 27. So you just basically have some sort of normal distribution, and you might not know sigma or mu for that particular normal distribution, which is what we're solving for. And you also have, or potentially have, some data point that's anywhere on the normal distribution. And what z is going to measure is how many standard deviations from the mean are you. So for example, if the standard deviation is 2 and the mean is going to be, let's say, 25, if your z value is, let's say, 2, then it just means that you're 2 standard deviations away from the mean. So for example, you would be at, your x value would be like 29 here, right? And that kind of makes sense. So you have 2 equals, 2 x minus 25. If you want to solve this, then you have, 2 equals, or 4 equals x minus 25, and x equals 29, which is basically just 25 plus 2 plus 2. So your z value really, and it can go negative, right? So you can go on either side of the mean. Essentially what it's telling you is just exactly how many standard deviations you are from the mean. So in a practical sense, we'll do a problem right now that has it. So let's just take this problem here. Let the random variable x be normally distributed with mean 25 as shown in the following diagram. The shaded region between 25 and 27 represents 30% of the distribution. Find the probability that x is greater than 27. Okay, so, well, if you know that this is 0.3, and you know that 25 is the mean, then you know that this is 0.5, because exactly half the values in a normal distribution will be under the mean, and the mean is 25. And then so, okay, well, the total area under the curve for a normal distribution is going to be 1, because the probabilities have to sum to 1. So then it leaves that this region is going to be 0.2. So you know that, okay, the probability that x is greater than 27, that's 0.2. So that's the easy part with 2 marks. Now we're looking for the standard deviation of x. So we do have a mean. We don't have the we don't have the standard deviation. But we do know exactly how many, like a bunch of the area values. So we're going to use the z value, which is going to tell us how many standard deviations 27 is away from 25 to help us solve for the standard deviation. And we can solve for z because we know a lot of the areas. So if you want to set up the equation here, first of all, let's do one thing. So, okay, what's the total area under 27? Well, the area under 27 is the complement of 0.2, or 0.5 plus 0.3. So the area under 27 is 0.8. And on our TID4, we can use the inverse normal function because, so here we go to inverse norm. And we use inverse norm whenever we have an area and we're missing either a standard deviation or a mean. So we'll use that one. So the area is 0.8. And we can use our normal distributions. Remember, the normal distribution is going to be the default value. Your mean is going to be 0 and your standard deviation is 1. And we're to the left side of 27, so we'll use the left. And we'll paste this here. And you'll see that we get 0.8416. And what that's going to tell us is that 27 is 0.84 standard deviations away from 25. Okay, so 0.84, this is our z value, is equal to x minus 25 divided by our unknown. And indeed, remember that our x here is going to be exactly this 27. So we have 27 here. Okay, so then solving for this, then we have sigma is equal to 2 divided by 0.84. And let's see what sigma is. 2 divided by 0.84. This made 2.38. So sigma is equal to 2.38 to 3 significant figures. Oops, 3.8, right? So 2.38. Now see, that's our answer. Yeah. Okay, so that's how you use it.